Dear students, now I'm going to explain phase transformations. There you need to study the entropy change. As you know, entropy change will take place either by absorption of heat or evolution of heat. Here also we'll study some physical change process, the process in which the physical change happens. There you need to study the entropy change. So one such important process is called as fusion process. Here you need to know the entropy change during this process. Here we should consider 1 mole of a substance that is solid, and this process will take place at its melting point of the solid, and we need to know the enthalpy change and the melting point of the solid. When you substitute these values in that equation, then you can get the value of entropy change. Therefore, entropy change is given by the ratio between enthalpy change and the temperature at which the process takes place. So it is given by delta HF by TF. This ratio is called as entropy change for fusion process. The next we have another important process is called as vaporization. In this process we can observe change of liquid into vapor. Here the entropy change is given by delta HV by TB or delta HV by TB, and this process takes place at the boiling point of the liquid. Hence the value of temperature you can call it as a TB or TV. The ratio between the enthalpy change and temperature is called as entropy change for your vaporization process. Next we have another important process, that is sublimation. As you know, sublimation involves physical change, that is a conversion of solid to gas. Here the solid directly pass on to the vapor state without becoming liquid. The best example is camphor. So during this process you need to calculate the value of delta S. The value of change in entropy during the sublimation process is given by the ratio between enthalpy change and the temperature at which the sublimation takes place. That is delta H by T, delta Hs by Ts. S refers to sublimation process. Next we have another important process. It is called as transition process. It is also called as phase transformation process. Here the substances exist in different allotropic forms at a particular temperature, and that temperature you can call it as a transition temperature. Take that value of enthalpy change during this process and the temperature at which the process takes place, then it is called as entropy change. The ratio between enthalpy change and temperature, you can call it as entropy change for transition process or polymorphic changes or polymorphic process. Next we have limitations of entropy concept of spontaneity. The thermodynamic criteria for determining the spontaneity of a process has a limitation. It only helps to predict whether a given process or reaction is thermodynamically feasible or not. It cannot predict the rate at which a reaction will proceed. There are other considerations which can tell whether the process will take place rapidly or slowly. Due to this limitation, the word feasible is used as synonymous for spontaneous or irreversible. A process may be thermodynamically feasible, but it may not proceed spontaneously. The example is conversion of hydrogen and oxygen gas into water liquid. Here you can't say whether the process is take place rapidly or slowly. So you can say only the feasibility of a process, but you can't say at what extent the reaction take place or at what rate the reaction take place. Next we have numericals related to phase transformations. The first numerical is related to vaporization process. Here the value of temperature is given. The example is water. The value of water is given, that is 373 Kelvin, and the value of enthalpy of evaporation is also given, that is 40.67 kilojoules per mole. So when you substitute that value in delta S equation, you can get 0.109 kilojoules per Kelvin per mole. Next numerical is related to the transition process. Here the transition temperature value is given for the sulfur. Sulfur has two allotropy forms, one is rhombic and monoclinic. So this will the conversion of the rhombic into monoclinic, that takes place at a particular temperature, that is 368.6 Kelvin, that is called as transition temperature. And the value of enthalpy change during this process is given by 322.17 joules per mole. When you substitute this value in the entropy change equation, you can get the answer 0.874 joules per Kelvin per mole. Another important example is related to fusion process. So when you take 1 kg of ice and it melts at 273 Kelvin, then the heat of fusion during this process is 334.72 joules per gram. When you substitute this value in this, you can get the value of entropy change, and is given by delta H fusion by T fusion, temperature of fusion. So the value of delta H fusion is 334.72 joules per gram, and the value of temperature is 273. When you substitute this, you can get the answer 1226 joules per Kelvin per kg. So this is the another example for transition process, phase transformations. With this I conclude the today's session.